just check your calendar. I think it was already on. Uh, it happened, I think, last Friday. Last Friday itself.
Sir, why does this time conflict with the maths timing, sir? The
Uh,
revision session for math is happening as well at the same time.
Mathematics 2, right?
Yes, sir.
Okay. Actually, it was, I think by mistake, classing was there. So what you can do, you can watch it. I mean, some those who are not there, they can watch it on YouTube later also. Meanwhile, is
Both
there
the
any
sessions are
session?
recorded, sir.
It's a recorded also. It's live on YouTube.
Okay, sir.
I
Okay.
have updated the calendar. I mean, YouTube link on the calendar itself. Okay. So I think tomorrow is mock session, right? Is there any session for mathematics tomorrow? Anyone?
Mock session
Yes,
is
sir.
there, sir.
Tomorrow also there is a session,
What is
same
the
time.
same
Mock
time?
session. It's a mock session.
Whole
Six
question paper discussion is what the heading says.
for mathematics, right?
Yes, maths
So
too.
it was by TA or it's by instructor?
I think so.
Tomorrow is
Instructor.
an TA session.
TA session, same time, right?
Yes, sir.
Okay, okay, no problem. Okay, so meanwhile, so
But the stats one is not clashing tomorrow. It's at 6 o'clock.
yeah, stats one is 6 o'clock. Yeah,
Yeah,
stats one is
that
separate.
doesn't clash.
Yeah, yeah, that doesn't.
Only today is the clash.
Okay, actually, I think see, main thing is this is the revision week, right? So every course has to cover the content in this particular week. So maybe that class happened by mistake. From the next time onwards, we'll try to avoid this kind of problem. Okay. So I think we can start, right? Or should we wait for something? Yes, someone has raised hand. Is there any issue? Someone raised hand. Okay. So I think should we start?
Yes, sir. We
We can, huh? Okay, no problem. Let me start it. Thanks. Okay. So let me share my screen. Okay. Can you see my screen? Anyone can confirm?
yes, sir.
Okay, fine. Yeah. Great. Okay, so do let me know at any step you are not getting the things. Okay. So today's main concept. Okay, one important thing as per the quiz point of view. So what you can do. So just prefer this solve with the PDFs. Okay. So just go through once the solve with the PDFs of all weeks. Mainly you can prefer for week 3 and week 4. Okay. So that will help you in I mean with respect to that your quiz one. Okay. So I mean if you are able to solve the questions of week 3 and I mean solve with the speed questions of solve with us of week 3 and week 4, then some questions you will be able to from in quiz one also. I mean concepts are related to that. Actually, that is one hint, or you can say. Okay, let's start the thing. So, what are the topics we majorly we have to cover? First one is in week 3 we are going to cover the expected value. Okay. Second one is the I think variance and covariance, right? Sorry, variance and standard deviation. Okay.
Yes.
Then we will cover the covariance. Okay. Then we will cover the correlation
Correlation.
coefficient. Okay.
Yes.
Then we will cover inequalities. Okay. Which are Markov's inequality. Okay. And then Chebyshev inequality. Okay. Then we will be covering. I mean, we will be moving basically to the uh, week 4, which cover the CDF. I mean, will actually CDF is a pool bridge from. uh, discrete to continuous. Then we will be moving to the continuous random variable. Okay. Then I think PDF. Okay. I think these are the major topics, right? PDM is probability density
Yes.
function. Okay. Okay. Let's start the very first concept, which is called the expected value. So we are going to consider, discuss the expected value, okay, of a random variable. As of now, we will be discussing for discrete random variable, because in week 3 we are going to consider for the discrete random variable. So what's the need of expectation? Actually, expectation is nothing but, suppose okay, suppose you have PMF, right? Suppose you want to describe your random variable, how you can describe your random variable? Like x is taking some value x1, x2, xn, right? And then probability associated with each value, this, let's say p1, p2 up to pn, such that all the probabilities are greater or equal to 0, and sum of all the probabilities should be equal to 1. So something, suppose you want to explain or you want to give the description about your random variable, you can simply tell us this. Okay. So expected value comes into the picture when you want to explain, or you want to explain, something about your random variable in a single value. Okay. Rather than giving the description like this, these points and this probability and all, if you want to explain, if you want to give the description about your random variable in a single value, so that in that case expectation comes into the picture. Okay, because expectation gives you a single value, and because it's called something central value, right? It will give you central idea about your random variable, rather than writing all the things about your random variable. Okay. So suppose, on how we can compute the expectation. Suppose your x is a discrete random variable. Okay. And let's say fx or p probability x equal to x. This is the, I'm saying PMF, probability mass function of your random variable. And normally we are denoting tx as the range of your random variable, right? So how we can compute the
Yes.
expectation? So expectation is nothing but, I think all of you are aware about, which is nothing but, it's a simply x1 p1, right? I mean value into respective probability plus x2 into p2, right? Correct? Plus up to
Yes, sir.
xn into pn. So this is something I can calculate the expected value. So basically we can write this is in the summation terms. X belongs to tx, means whatever the range of x is there, then x into respective probabilities. Okay. Or I can write down this x into probability x equal to x. So this is the same. This means we are treating as a PMF, probability mass function of your random variable. Or if you talk about like this, so I can simply write down expectation of x in equal to summation of xi into pi. I mean, all are the same. The only thing we have to see value into corresponding probability plus value into corresponding probability, right? So this is something we can we are defining expectation of a random variable. For example, let's do one example. Suppose okay, can you tell me? Okay, suppose x is there. Okay, I'm saying x is taking value 1, 2, 3, and 4. Okay, and probabilities for each value is for our simplicity, let's make it 1 by 4, 1 by 4, and 1 by 4. Okay, every one of you have pen and paper right now.
Yes.
Okay, can you calculate
Yes.
me calculate expectation of x and tell me? Then I will be able to know. Yeah, you are getting the point.
5 by 2.
So 2.5.
2.5.
2.5.
Yes, 2.5.
Okay, I don't know answer. Let's calculate.
2.5.
So basically, what we have to do? 1 into 1 by 4, right? Plus 2 into 1 by 4 plus 3 into 1 by 4 plus 4 into 1 by 4. So it's the 4, 3, 7, 2, 9, 1, 10 by 4, which is 2.5. Yeah, you are right. So 2.5 is the correct answer. So I think it's a simple one, right? Is there any doubt related to this?
No, sir.
No,
No?
sir.
Is
No,
that all
sir.
right for everyone?
No, sir.
Fine. Okay, what if suppose I'm saying a random variable is defined like this? Suppose I'm saying, okay, suppose x is there. Okay, it is taking, suppose for x1, some bar is there. For x2, let's say some bar is there. And on the y-axis, probability is there. Suppose p1, and this is the p2. Suppose for x3, okay, This is the probability P3, for example, and for X4, this is the P4. How will you calculate the expectation of X? Tell me.
Sir, multiply each value with its
This one,
respective
right?
probability.
X1
Correct.
into
So
P1,
Yes.
X1 into P1 plus
X2
X2
into
into
P2.
plus X3
P3.
into P3 plus
P3.
X4 into P4. So
P4.
basic thing, we have to keep in mind the expectation formula actually. That's all about that thing. Okay. Now, if
Yes.
it's clear, so I think next one is expectation of function of random variable, right?
Yes, sir.
So what do you mean by function of random variable? Basically, okay, so how we are defining this? Suppose I'm saying I have x1, x2 up to xn. I mean the random variable are taking these values, x1, x2, xn. Let's make it small. Okay, let me talk about in general. Okay, suppose I have, okay, let's do like this. X1, x2, xn. Okay. Okay, for this, let's say PMF is f x1, x2, xn. Okay. Now I'm going to define a random variable which is defined as a function of x1, x2, xn. It can be anything. Let's say if you have a random variable x, it can be x square, it can be 2x plus 3, anything, right? Which is nothing but any function of xi, right? Now, so how will you compute the expectation of y? So to calculate the expectation of y, what are the things we require? We have to, first of all, we have to calculate the PMF of y, yes or no,
Yes, sir.
and range of y, right? Yes or
Yes.
no? So similarly, expectation of y will be basically this means expectation of the, it will be function of x, x1, x2, xn, right? So
Yes,
that
sir.
means I can simply say y belongs to ty means all over the range y into f of y of y. So it's the same as expectation of x equal to summation of x x into f x of x means values into corresponding probabilities. So it means it can be any function of your random variable x. Okay, let me take one example that will give you some idea. Okay, suppose I'm saying x is defined as a uniform distribution. Let's say it's taking value minus 1, 0, and 1. Okay. With then probabilities will be 1 by 3, 1 by 3 because if it's a discrete uniform, right?
Yes.
Correct. Now, so thing is that suppose I'm saying a random variable y has been defined as the gx, which is nothing but let's say I'm talking saying x plus 2. So x plus 2 is the function of your random variable,
Yes.
right? So we have to calculate the what is the expectation of y. So to calculate the expectation of y, what we have to do? Summation of y into fy of y. Correct.
Yes.
So first of all, we have to find the values of y. Okay. So what are the values of y? If you will add 2 to all this value for this. Okay. So x is defined as minus 1, 0, and 1. Y is x plus 2. If you will add 2, it will be
1,
1, then 2,
2,
then 3, right? And what is the probability? It will be 1 by
1
3,
by
1 by 3,
1
1
by
by 3.
1.
Now, you have values of y, you have respective probabilities. I can simply calculate the expectation of y from here,
Yes.
right? So it will be 1 into 1 by 3 plus 2 into 1 by 3 plus 3 into 1 by 3, which is 6 by 3, which is nothing but 2.
2.
Yes or no? Now,
Yes.
here you can use the property as well. What is the property? What I mean by the property? So expectation of y is nothing but expectation of x plus 2, right?
Yes.
So here I can write expectation of x plus 2
Yes.
because expectation of a constant is a constant value, right? Now
Yes.
the thing is here you have to find the expectation of x. So what will be the expectation of x here? It will be minus 1 by 3 plus 0
0.
plus 1 by 3, which is nothing but 0, right? So here 0 plus 2, which is 2. So if you see, in both way, we are getting the same answer, right? So both approach is correct. Okay, is that all right for everyone? Any doubt?
Yes, sir.
Sir,
Clear.
sir, please scroll light. Last point, sir. Last one.
This one?
Last. You calculated above, sir. One you
Uh,
calculated. Yes,
this
yes,
one?
yes. Yes, yes. Zero, zero. Okay, got it, sir.
Got it? Minus 1 into 1 by 3
Yes, yes,
plus
got it.
0 into 1 by 3 plus 1
Yes, yes,
into 1.
yes.
Okay, fine.
Expectation of X only.
Yes, yes. So you
Okay,
can
sir.
do, you can proceed with both approach. So here some of there are some properties of expected expectation you can keep in your mind actually, that will help you actually. So what are the properties? First of all, expectation of a constant is a that value. Okay. Hope you are aware about this. Okay. I'm not going to do the derivation, or do you want to do me the derivation?
No, sir, it's
No,
clear.
sir. No, sir.
Clear?
No, sir.
Okay. Okay, it's clear. Okay, let me give you some hint so that you can. Okay, suppose x is taking only one value, which is 2. Then what will the probability? Probability will be 1, right?
Yes.
Then what will be the expectation of x? 2 into
2.
which is 2, right? So that means expectation of a constant is that value, right?
Yes.
Okay. Okay. So if this is the case, now you will tell me what if expectation of let's say I'm saying c plus x. So it will be expectation of c plus expectation of x, right? Which is same as
Yes.
c plus expectation of x, right?
Yes, sir.
Yes or no? Is this what about
Yes, clear.
expectation of c times x?
C into expectation of X.
C into expectation of x, right? Now, yeah, that's all right. What if expectation of x plus y?
Expectation
Expectation
of
of
X
x
plus
plus
expectation of Y.
expectation of y. Okay, irrespective of the whether x and y are independent or not. Okay, it doesn't matter in case
Yes.
of expectation. Okay, what if suppose I'm saying expectation of ax plus by? So I can write this as expectation of ax plus expectation of by.
Yes.
Yes or no? So from here I can simply write a times expectation of x plus b times expectation of y. Yes or no?
Yes.
These are some properties you can keep in your mind. Okay. So okay, there is one more thing. Can I write expectation of x into y equal to expectation of x into expectation of y?
Only
Always
if X and Y are independent.
correct. I can write this only if x and y are independent. So we'll move. I will cover these things later. Why we are writing this thing actually? Why it will? I mean, why only x and y are independent? Then I will write expectation of x into y as this like product of individual expectation. I will tell you it later. Okay. Now, suppose okay, let tell me one more just a question. Suppose I'm saying there is two random variable x and y which are independent. For example, okay. Now I'm saying with expectation of x is let's say e1, expectation of y is let's say e2. Okay. Then I'm saying variance of x is let's say v1 and variance of y is let's say v2. Can you tell me variance of x into y in terms of e1, e2? Okay, I think I have not covered the variance. Okay, let me come to the point. Okay, let's do it little bit later. Okay, I think I should first do the variance part. Okay, so I think after this variance is there, right? So far so good.
Yes, sir.
Okay, okay. So next concept is variance. Okay, actually, what's the need of variance? Actually, suppose expectation tells you the gives you a central idea about your random variable in a single value. So why, what's the need of variance? Actually, this is called the measure of dispersion. Measure of dispersion is it will tell you how much I mean about what I mean
Spread of
variability.
the random
Yeah,
variable.
variability in your data set, spread of your random variable and all. Okay. So basically, why need of variance? Because suppose there is two university or two college, something like that. Okay. Suppose okay, let me do in general. Suppose you have two data set, 1, 2, 3, 4, and 5. Okay. And there is another data set, let's say 3, 3, 3, 3, and 3. Okay. So what will the mean for this? It will be 3, and mean for this it will be 3, right? So by with the only help of mean, can you say both data is same? data 1 and data 2? Both
No,
data
sir.
are
No, sir.
same? No, right? Because in the data 1, okay, which data you will prefer?
Data 2
Data 2. Why?
Two.
because
Because
of the consistency.
consistency, because there is less variability, right? So basically variance comes into the picture to know the variability of the data set from its mean. Okay, so how we are defining the variance basically? So variance of a random variable is nothing but defined as expectation of x minus mu whole square. Okay, let me tell you what is the mu. Mu is nothing but expectation of your random variable. Okay, so if you will expand this formula, so you will get expectation of x square minus expectation of x whole square, right? Am I correct?
Yes, sir.
Okay, so I'm not going to do the derivation, or should I do? It's up to you. Is that all right? Then we can move ahead.
It's all right.
It's all right. Okay.
Yes, sir.
Okay, so this is the, I mean, this is the another form. Basically, this one second form is more preferable. Preferable means suppose expectation of x you have calculated for any data set. You can calculate simply this one, because x square is nothing but it's a function of your random variable, right?
Yes, sir.
Yes or no?
Sir,
Because yeah.
just want to confirm one thing.
Hmm.
The above you wrote expectation of x minus mu.
Hmm.
In that whole square should be inside those square braces, I
Yeah,
guess.
it's the expectation of x minus, yeah, it's a square for this part only.
Okay, okay, okay.
Okay. Okay, so actually, you can calculate this because okay, suppose tell me, let me do this one thing. Okay, suppose I'm saying I have random variable x and y, for example. Okay, suppose I'm let me take this one. It's follow uniform minus 0, minus 1, 0, and 1 with probabilities 1 by 3, 1 by 3. So what will the variance of x? Okay. So to calculate this, I need expectation of x square minus expectation of x whole square, right? So expectation of x. So what we have to do? First, we have to calculate the expectation of x, right? What is that? Minus 1
0.
into 1 by 3. Yeah, it will be 0. Now, what is the next thing? I have to calculate the expectation of x square, right? That means I have to do summation of x square into fx of x, right?
Yes,
Okay, that is the something we have defined, right? Expectation of any function of gx. This is nothing but summation of gx into probabilities, right?
yes,
Yes or no? So this gx is x square. So this means we have to do the square of the values, right? That means minus 1 square into corresponding probability plus 0 square into corresponding probability plus 1 square into corresponding probability. So basically it will be 1 by 3 plus 0 plus 1 by 3, which is nothing but 2 by 3. Is that all right so far?
yes, sir.
So variance of x is nothing but expectation of x square minus expectation of x whole square. So 2 by 3 minus 0 square, which is nothing but 2 by 3. So 2 by 3 will be the answer for this question. Is that all right? Any doubt?
Yes, sir. No doubt.
No doubt? Okay, great. Okay, so and I think next one is standard deviation, right?
Yes,
Okay. So standard deviation is nothing but defined as the square root of the variance of x. So okay, anyone of you can tell me why we are doing the square root of, and what's the need of a standard deviation?
To maintain
sir.
the unit
Because
cell, sir.
Correct, correct, great. Basically, standardization is the same thing, but to know the things, I mean, it will be easier to compare the things in terms of original units. For example, suppose your random variable x is, let's say, age of person, okay? Age of some person is given to you. Then this data will be in year, right? Okay. Suppose
yes,
you have calculated the variance, let's say it's coming out to be, let's say, V1 year square. Okay. Then standard deviation will help you to take, if you take the square root of x, then you will get the square root of V1 into year, right? So your variability things will be in the same unit as of the your data set. So it will be easier to do the interpretation, comparison and all. Is that all right?
yes, sir.
Fine. So let's move to the some properties of your expectation. Sorry, variance. Okay, that is something also important. Okay, so what if variance of a constant, that's C itself, right?
Yes, C.
Okay,
0.
0, it's not C. See, expectation of that constant value is C, not variance. Why? Okay, let me derive. Suppose variance of x is defined as expectation of x minus expectation of x whole square, right?
Yes.
Right? So what if variance of a constant C? So it will be expectation of C minus expectation of that constant, right?
Yes.
So expectation of C, and we know expectation of a constant is that constant itself, right? So it
Yeah.
will be 0. Okay. See, variance, just think variance of a constant number. There is no variability at all.
Yeah.
Okay. So variance of a constant value is the, I mean, it will be 0.
0.
It will, it's all right.
Yes,
What
sir.
if
It's
variance of A times X, where A is a constant?
A square into variance of
A
x.
is square into variance of X. Okay. So, and similarly, standard deviation of A times X. So it's a
A into standard deviation x.
square root of variance of A times X. So it will be basically square root of A square variance of X, which is nothing but A times standard deviation of X. Okay. Now, basically, this is the modulus value. I mean, it should be positive. What if variance of X plus A?
That's only variance of x.
Variance of X plus variance of A, but this will be 0. So I will get variance of X only, right? Same for standard deviation also. Yes or no?
Yes, sir.
Okay. Now, so one more thing here you to keep in mind. What if variance of X plus Y?
Variance of x plus variance of y.
Always.
But
minus 2
no, but
covariance
x
of
and y
x1.
should be independent.
Correct.
Independent.
Actually, this summation is defined as variance of X plus Y equal to variance of X plus variance of Y plus 2 times of covariance of X comma Y. This is the something variance of X plus Y is there. But when X and Y are independent, if X and Y are independent, then this
Covariance
covariance
is
of
0.
X comma Y is 0. If this is the 0, only then variance of X plus Y will be variance of X plus variance of Y. So you have to keep in your mind, if X and Y are independent, only then this will be true. While in case of expectation, it doesn't matter. Okay, it will be always true. Okay, so you have to keep in your mind actually. Okay, so this is the case actually. Okay, so if okay, let me tell you why this is the case, because I will come to a little bit later. So covariance is defined as expectation of X into Y minus expectation of X into expectation of Y. Would you agree
Sir,
with me? Okay.
sir,
Yes.
small doubt, sir.
Yeah, please go ahead.
And this, how this is related to covariance, sir? Two covariance x comma
Okay,
y.
so this is the formula. We are not going into the derivation. Okay, so if you will do variance of X plus Y, okay, so this value will be same as this one.
Okay, okay, sir.
Okay, we are not going into the derivation part. I mean, that's not important for this, at least for this one. Okay,
Oh,
so
okay,
this
sir.
is the, okay. I was just telling you from where it came. Okay,
Right, right, right.
so this is
Right.
the objective behind it. Okay, so we can do it later also, right? The why, from where it came, we can discuss it later. Okay,
Okay, got it.
okay, fine. So I think this covariance is all right for everyone. This covariance, how we are defining. Okay, okay. Let me go ahead from the. Okay, tell me, as of now, it is all right for everyone so far. Variance
Yes, sir.
expectation. Okay.
Yes,
Now,
sir.
okay. Let's move to the covariance part. We'll discuss from here itself. Okay.
Sir, one more that variance of x minus y is also there, no?
Yeah, correct, correct. So what if variance of X minus Y? If suppose X and Y are independent, I'm just treating this one.
Sir,
That's
variance of
also
x minus
Vx
variance.
plus Vy.
Variance of X, basically it will be plus minus 1 square variance of Y. So it will be variance of X plus variance of Y. Okay. Okay.
Yes, sir.
Basically, okay. What's the agenda behind this? Okay. Let now hopefully let I think maybe you will get the idea if you will do the things right. If you will expand this one, okay, I'm not going to write. I'm erasing this one. Okay, why this is the something we are getting. Basically, variance of x minus y is defined as variance of x plus variance of y minus 2 times of covariance of x comma y. Actually, this is the minus 1 square. So if x and y are independent, so it will be 0. It will be variance of x plus variance of y. Okay, this is the something.
Yes.
Okay.
Sir, is there any sum property of standard deviation also, just like variance?
Yeah, the same thing, right? You can
Okay.
apply.
So
Okay.
in the standard
Okay, okay.
deviation,
So, okay. No, no. I mean, in the standard deviation, what you will do? Suppose I ask standard deviation of x plus y, right? So, you cannot directly write this one. So, what you can do? Just calculate this variance of x plus y and simply take the square root of variance of x plus y. Got it?
okay, understood.
Understood? Okay. Because
Yes.
standard deviation is nothing but the square root of that. So, it's very simple. I mean, rather than getting confusion, suppose variance you have calculated as 4, then the standard deviation of that thing will be 2.
Yes.
Clear?
Hello.
Okay, yeah.
Hello.
Yeah, yeah, please.
Yeah, sir, I had a doubt on the topic of variance in one of the activity questions.
Which, okay, okay. Okay, tell me which activity you are.
Sir,
Your voice is not coming. Can you paste on the this
sir,
chat box course?
sir, sorry, I didn't hear you. What did you say?
Okay, can you paste your question in the chat box? Okay.
Sir, it contains an image of distribution. No, I can't paste it.
Okay, which activity you have? I think activity and all you can discuss it later. Okay, no problem. Just tell me in which activity you had out.
Sir, 3.4 last question.
So what is the doubt here? It's a very simple.
Sir,
Huh?
sir, actually, I'm getting the answer via the brute force method, like simply calculating it, multiplying it, and addition.
Hmm.
But the second approach I want to discuss is that can we subtract 2 from each value of the random variable,
Hmm.
and then the values will be from 1 to 7, and then we can apply the direct formula for discrete uniform random variable n square minus 1 by 12.
No, no. So you want to do x minus 2, you mean?
Yeah, yes, for each value. So the spread of the data won't change. So the variance won't change.
Okay. So
Uh,
I
so
so then I think you should get the correct same answer, right?
yeah, so I wanted to just ask that is that the correct method or not?
You can do. See, are you getting the correct same answer? First of
Yes,
all,
yes,
tell
I'm
me.
getting same.
See, anyway,
Yes,
anyway, you mean you are going to do variance of x minus 2, which is same as variance of x. Okay.
yeah, yeah,
This means the you are going to calculate by this or by this. It's the same thing, right?
yeah. Okay.
Yeah.
Thank you.
Yeah. Okay. So, what covariance tells us basically, covariance tells us the linear association between two random variables, two numerical random, that means x and y. Okay, how it defines actually? So covariance of x comma y is defined as basically it says expectation of x minus expectation of x, okay, into y minus expectation of that random variable. Okay, or if you will solve this one, right, so it will give you the same answer, expectation of x into y minus expectation of x into expectation of y. So this is something I can define the covariance between two random variables. Okay, so this is, I mean, you can use anyone, not a problem. You can use this one or this one, but this one is looks something in a simpler manner. Okay, what if, tell me, I will ask covariance of x comma x.
It's just variance of x.
Yeah, so it will be x square, right? Minus expectation of x it will be whole square, which is nothing but variance of x. Okay, now you got the idea, this variance of
Yes.
x and covariance some more. Okay, yeah. So thing is that if, okay, one property, the things which we have discussed lots of time, if x and y are independent, okay, if x and y are independent, so this means covariance should be 0, right?
Yes.
If covariance is 0, that means I can say expectation of x into y minus expectation of x into expectation of y should be 0.
Yes.
If this is the case, then expectation of x into y should be equal to expectation of x into expectation of y.
Yes,
Okay.
sir.
So this is the true only when x and y are independent. Okay. In case of expectation, expectation of x into y, you can write as a expectation of x into expectation of y when x and y are independent. You can keep in your mind. Okay. Now, okay, can you tell me if x and y are independent, then I'm saying covariance is 0. Can I say if covariance is 0, then can I say x and y are independent?
No, sir, not always.
No, sir.
Not always, right? The
Yes.
only thing I can conclude from here, because covariance tells me the linear association, I can say x and y are not linearly related. Yes or no? If
Yes.
covariance is 0, it means they can be related something. When suppose x is defined something and y is defined as x square, it's possible covariance between x comma y is 0. But x and y are not linearly related. There is some dependency except the linear association. Okay, is this clear? I mean, this is some just uh, you can say some conceptual things we are going to
Yes,
discuss.
sir, this is clear. So, sir, the thing you asked earlier, that variance of x and xy,
Hmm.
that is equal to covariance of x and y, right?
No, no, variance of x into y is not equal to covariance of x. That's why I told you just prefer the solve with the PDFs. It will be helpful because, okay, why I'm going to discuss that one, because let me open here. Take okay, let me tell you something. Okay, suppose I'm saying I'm going to give you information x and y are independent. Okay, with some,
Yes.
let's say, expectation E1 and expectation of y as E2 with some variance, let's say V1 and variance of y as V2, correct? I'm saying x and y are independent, then calculate the variance of x into y. Okay, so you cannot directly write here variance of x into variance of y, right? You can't do,
Yes, you can't.
correct? So one hint here is there, if x and y are independent, then I will say x square and y square are also independent. So how will you compute? Okay, how variance is defined? So variance of any random variable is defined as expectation of x square minus expectation of x whole square,
Yes.
right? So from where can I write expectation of x y x square y square minus expectation of x into y whole square? Yes or no?
Yes.
I can write. Okay. Now we know if x and y are independent. Just a few seconds before we have seen if x and y are independent, I will say expectation of x into y is same as expectation of x into expectation of y, right?
Yes, sir.
Now I'm saying x square and y square are also independent. That means I will say expectation of x square into y square is same as expectation of x square into expectation of y square. Can I say or
Yes.
not? Would you agree with me?
Yes.
Now,
Yes, sir.
so from here itself, if you see, I can write this as expectation of x square into expectation of y square or not. The very first term.
Yes.
Minus inside the bracket here. This is the independent. So I can write expectation of x into expectation of y because these two are independent. Yes, no?
Yes, sir.
So this one you can write expectation of x square into expectation of y square minus. I can write down this one as okay. Let's write down. Okay, let it be. Okay, can you tell me you have been given variance, expectation, expectation. So here you can simply put the values of expectation of x and expected value of y, right? So I can simply write down e1 into e2 whole square, right?
Yes, sir.
Okay. Suppose this is 2, this is 4, then it will be 8 square. Correct? What about this?
Yes.
Since you have variance, which is v1, and we know variance of any random variable defined as expectation of x square minus expectation of x whole square. So from
Yes.
here, can I calculate expectation of x square, which is variance of x plus expectation of x whole square?
Yes,
This
sir.
value, because in this equation we don't know this value, right? We know the variance. So with the help of variance formula, I can calculate the expectation of x square or not.
Yes, sir.
We can,
Yes,
right?
sir.
Everyone is getting this point.
Yes,
Yes,
sir.
sir.
Okay.
Yes,
So
sir.
this variance is what? V1, and this is the E1 square is equal to expectation of x square. So we can substitute this value here itself. Similarly for y. So similarly for y, it will be V2 plus E2 square as expectation of y square. Is this clear? Okay.
Yes, sir.
Okay. This is just some random question. So this kind of concept will help you. Now, I think next one is there are some when your covariance can be positive and negative and all. Okay, some properties you can say. Can you tell me when covariance of x and y will be positive? So in covariance, how covariance is defined? First of all, expectation of x minus expectation of x, right?
Yes, sir.
Y minus expectation of y. So when it will be positive, if x minus expectation of x, sorry, into y minus expectation of y, product of these two should be positive, right?
Yes.
When product of these two will be positive,
If both are
Greater than
positive
0.
or both are negative.
if x is above or below its mean, right?
Yes.
And y is also above and below its mean, correct?
Yes.
Okay, what is the meaning of above and below? Because if x is above its mean, that means I mean this will be positive value, this will be positive value, right? In that case,
Yes.
product of two positive numbers will be positive. If both are below, that means this is the negative, this is the negative, then product of two negative number will be negative. Yes or no?
Positive. Two product of two
Sorry, yeah,
negative.
product of two negative number will be positive. Yeah, sorry.
Yes.
Thanks for the correction. Okay. So similarly, covariance of x comma y will be negative
When one of them is
Above
negative.
and below.
One is above.
correct. So I mean this product of these two should be negative, right? Correct.
Yes, sir.
If this when it will be negative, if x is above
Above.
its mean, right? In the similar way, y is below its mean, right?
Yes.
Okay. Or x is below its mean, then y should be above its mean. Yes or no? Okay.
Yes,
Yes,
sir.
sir.
Let me draw one graph that will maybe give you some clear idea. Suppose this is x and this one is the y. I'm just assuming x bar is here somewhat and y bar is here. Okay. Suppose these are the four coordinates. Okay. Tell me what about xi minus x bar here? It will be negative or positive?
Negative. Positive.
Negative, right?
Yes, sir. Negative.
Yes, negative, negative, negative.
Yi minus y bar
Negative.
in this part, xi minus x bar
Positive.
positive, correct? Yi minus y bar
Negative.
in this part
X bar and Y both will be positive.
both positive, right? In this part
X
X will be
positive.
negative, Y will be positive.
negative. Okay, y minus y bar will be positive. Okay, so if you see the product one, right? So product of these two will be
Negative.
right, and
Negative.
product of these two I'm writing as
Positive.
Positive.
In this case, product.
Negative.
Negative.
In this case, product.
Positive.
Now you got the idea when it will be positive and when it will be negative,
Yeah.
Yes, sir.
right? Now, so there are some properties of covariance as similar to the variance. Okay, I mean, what are the properties? I'm just going quickly. So we have just seen the this one, right? Where the covariance of two with the same random variable, nothing but variance of that random variable, right? Also, I can say covariance between x comma y is same as covariance between y comma x, because it's just a product of xi minus x bar into yi minus y bar. Yes or no?
Yes, sir.
Okay. There is some another thing, covariance of, let's say I'm saying x comma ay plus bz, some three random variables. Then how will you define? It will be covariance between x comma ay, right? Plus
Yes.
covariance of x comma bz. So it will be simply a times covariance of x comma y plus covariance of b times covariance of x comma z. Okay, this is okay. Now let me give you one question. Okay, you will tell me how to do that one. Okay, basically. Now, so so suppose I'm saying I have this x as the random variable. I'm going to give you some joint PMF table. Suppose this is 0, 1, 2. Okay. Let's say 0 and 1. So suppose this is the 0 by 9. Okay. 1 by 9, 2 by 9. Okay. So 1 by 9, 2 by 9, 3 by 9, 3 to 5, 5, 9. Okay. 9 by 9. So this is the valid PMF. Okay. Now, so question is you have to calculate the covariance between x comma y. So you have to do expectation of x into y minus expectation of x into expectation of y. Yes or no?
Yes,
Yes,
sir.
sir.
Correct. Now tell me, okay, how will you proceed? First of all, I
First,
have to
we'll
calculate
find.
expectation of x, right?
Yes.
So expectation of x to calculate it should be we need x into px, right? So we have to calculate the first of marginal PMF, right? Fx.
Yes, sir.
So it will be 1 by 9 and it will be 3 by 9 and it will be 5 by 9. Addition of these two quantities. Everyone is getting?
Right.
Yes,
Right?
sir.
This is something we are calculating the marginal PM. It will be 3 by 9, it will be 6 by 9, total is 1. So expectation of x will be, how will you calculate expectation of x? It will be 0 into 1 by 9, yes or no? Plus 1 into 3 by 9 plus 2 into 5
5
by
by 9.
9. There are some background noise. Okay. Yeah, thank you. Okay, so I'm not going to calculate the value. I mean, let's calculate. So 5 to, I mean 10 and it should be 13 by 9, right?
13 by 9.
Same for expectation of y. So that means in case of expectation of y, it will be 0 into 3 by 9 because this is the PMF probabilities for value of y, right? So 0 into 3 by 9 plus 1 into 6 by 9, which is nothing but 6 by 9, right? Now main part is expectation of x into y. So if you see how we are calculating expectation, so it should be summation of x into y into joint probabilities, right?
Yes.
Correct? Because this is, so what we have to do, that means, let me use some different color. Let's me do it green one. That means you have to do 0 into 0 into 0 by 9 because
Yes.
these are the values and this is the corresponding joint probability. Yes or no? So I'm just
Yes, sir.
writing 0 here itself, okay? Because it will be 0, correct? 0 into 0. Then next is 0 into 1 by 9. Again it will be 0. Everyone is getting?
Yes, sir. Yes.
Yes, sir.
Okay. Then next will be 0 into 2 into 1 by, sorry, 2 by 9. Again it will be 0 because 0 is
Yes.
something, it will be 0, right? Now, next one is 1 into 0 into 1 by 9, right? Again it will be 0. Then 1 into 1 into 2 by 9, right? Plus 1 into 2 into 3 by 9. So 1 into 2 into 3 by 9. So basically, if you see this term is again 0, so it's 3 to the 6 to 8 by 9, right?
Yes, sir.
So expectation, sorry, covariance, it will be, we have to just apply the formula 8 by 9 minus 13 by 9 into 6 by 9. So is that all right? How will you compute the covariance?
Yes, sir.
So out of all the 6 entries, 4 become 0 and 2 is non-zero, right?
Yeah, for 2 are non-zero because 0 into something, it will be 0 at all.
Hmm.
The main point was how to calculate this expectation of x into y, because sometimes people make mistake. That's why. Okay.
I think for this, just to avoid the error, I think we should first write all the joint probability and then x and y value. That way we can avoid the
Yeah.
committing mistake.
Yeah. Correct. Okay. So next one is the correlation. Okay. So what's the use of correlation? Basically, first of all, okay, let me tell you. Suppose I'm getting covariance of two random variables, let's say 152. Covariance between x comma y as let's say 500. And covariance of x comma y, I mean these two are some different random variable, not for a single data set itself. Let's say minus 50, and covariance of x comma y, let's say minus 150. So by observing these value, I can only say there are a positive linear association between x and y, and there are negative linear association between x and y. Yes or no? Right? But can I tell something strength of linear association? I mean, which one is the greater? Can you say whether which one is the better?
500.
I mean, as of for this 500 is better, but we can't say this is the strong one, right? Are you getting my point? What I'm talking about? See, by 500, see, for some data set, it can be 52. Okay. This is the positive linear association. But can I tell about something? This is the strong positive association.
Okay.
Which one is the strong? No, I mean, we can't say, right? We can only say this is the positive linear association or negative linear association. So we can say strong or weak or something like that when we will be having the boundary. Only in that case, I will say, right? Yes or no?
Yes, sir.
Correct?
Agree.
Yes, sir.
Are you agree? I mean, are you getting my point, right?
Yes.
If you have boundary, suppose in case, okay, let me tell you with the help of, if actually correlation coefficient have the boundary of -1 to +1, okay. So if any value is close to +1, let's say 0.98, then you will say there is a strong correlation, right? Okay. But by the seeing only covariance value, you can't say there is a strong linear association. We can't say. Yes or no? Are you getting what I'm trying to say? Yeah.
Yes, sir.
Okay.
Yes, sir.
One major property is also correlation is unitless measure. Okay. Why unitless measure is this? Let me tell you. Basically, correlation. This is
This
the rule.
coefficient.
Is defined as covariance between x comma y divided by standard deviation of x into standard deviation of y. For example, suppose x is the your age, then it will be in year, right? Suppose y is the weight of person, then it will be in kilogram. Okay. Then what will be the unit of covariance? It will be year into kilogram, right? Same for standard deviation, it will be year into kilogram. Yes or no? So unit will get
Yes,
cancel
sir.
out. So that's why correlation is the unitless measure. It's called unitless measure actually. Okay. And you know this lower limit and all. So there's a derivation behind it. We are not going to that. One more thing, you can plot scatter plot to get a quick idea what kind of linear association is there. Okay. Okay. So far so good. Any doubt?
No, sir.
No? Right. Is that all right for everyone? Then
Yes,
let's
sir.
move to the inequalities. Okay. I think I can remember now in week 3 of presentation, someone told me for mathematics behind the Markov inequality, right? not able to recall who's
I was the one, sir.
Biplav. Okay, okay.
Yes.
I think it was missed out. No worries. We'll I can. I mean, it's in mind. In my mind. We can discuss. Okay. Okay. So there are two important inequalities, which is called the Markov's inequality. Okay. So how it defines? Okay. So the Markov inequality and Chebyshев inequality are actually very important. Okay. So you can get some questions related to this inequality. Okay. So try to cover the concepts. Okay. And don't worry about, first of all, let me clear something. Don't worry about formulas and all. Everything will be provided to you in formula sheet. All the distribution, PMF and PDF of all the distribution with expected value and variances also. And along with what is the Markov inequality, Chebyshев inequality. Only thing is required from your end is just you need to be clear with the concept in which scenario what to use. Okay. Inequality and all, everything will be provided. No need to memorize the what is the PMF of binomial distribution, geometric distribution, expectation of geometric, nothing. The only thing is you have to apply. You should be careful when to use this thing. That's all. Okay. Now let me describe the Markov inequality.
So one minute, sir, in the exam, all the formulas will be provided. Sorry to interrupt. All the formulas will be provided in the exam.
Yeah.
In the quiz one, everything will be provided.
Okay. Let me okay, one second.
Formulas.
Yeah. Let me, okay, one second. Just give me a second. I will show you something.
Not
Because I was
not
studying with all the
not all
formulas.
100%. Some 10% you need to know, and 90% will be there.
No, don't worry, don't. Just give me a second. I will show you what formula I'm talking about. Okay. Just give me a second. Yes, I'm searching.
I think it is there in the portal itself, the login.
Is it?
I think I have seen somewhere, and supplementary content.
Okay, because
Okay, can you search that one? If it's there, can you share?
yeah, because people for working and all, it's not like college. We
Yeah,
know all formulas.
that is the main concern actually. That's why we are providing the formula sheet. Okay, let me show you something.
I think it is there in the supplementary content, if I'm not wrong, but need to see which one exactly in that.
Okay.
I think it is in the short notes, if I'm not wrong. Let me see.
Okay, one second. Let me share my screen right now. Okay.
So that will be very good.
Yeah, that actually your name, I don't know your name. It's RH. I don't know. Okay, so actually this is the formula set you will be provided, like distribution, PMF, CDF, expectation, variance. Okay, there is no need to memorize the formula. Okay, our main
That's
concern is
fantastic.
okay, that is until here till Chebyshев inequality, it will be given to you in your just before the questions. Okay, the only thing is there you have to how to apply, it's your this is something you have to do from your end. Hope that is all right for everyone. Okay.
You don't
Yes.
know gamma.
So, sir, one doubt is, this is fine. The Markov's inequality is also fine, but in the Chebyshev's inequality, I get confused whether it is upper bound or lower bound.
Don't worry, we'll clarify. Don't worry, I'm there.
Okay, I would
We'll
love
discuss.
this both are things to be clarified, Marcos and Chebyshev's.
Sorry, can you repeat?
No, I would
Hello?
like these inequalities to be clarified because I get a little
Yeah, sure.
muddled.
I'm just going to explain these things. Okay, don't worry. Okay.
Sure. Thank
Okay.
you so much.
Yeah. So yeah, thanks. Okay. So Markov inequality is defined as nothing but suppose x is your discrete random variable. Okay. X is your discrete random variable which is taking only non-negative value. This is the condition. Okay. We will go in the history of this Markov inequality later, but as a point of revision point of view, let's focus on the content only. It will take only non-negative values. Okay. And suppose expectation of x is mu. Okay, mu is some value for expectation of x. Then Markov inequality is defined as probability that x greater or equal to a constant it should be less or equal to mu by c, where mu is nothing but this is the expectation of that value itself. So this is defined as something Markov inequality. Okay, so what is this? Can I say this is the upper bound? Upper bound means this content, sorry, not content, this quantity will not exceed this mu by c. Yes or no?
Yes, sir.
Yes,
Okay,
sir.
so that means this is the upper bound. Okay, let me take some example. Hopefully that will give you idea. Suppose I'm saying x is following geometric distribution with probability, let's say 1 by 5. Okay, if this is the case, what is the expectation of x? It's a 1 by p in case of geometric. So 1
Yes.
by 1 by 5, which is nothing but 5,
5.
right? Now, tell me, what if I will ask probability that x is greater or equal to 20 by this formula? Tell me what it will be.
Less than 1 by
Less or equal to
20.
5 by 20.
5 by 20. That means less or equal to 1 by 4.
Yes.
Is this clear? Are you getting?
Yes, sir.
Yes.
Now, just tell me, suppose I will ask, okay, so this probability x, okay, let me tell you, this is the bound, okay, not actual probability, okay, not exact value. This is bound means, suppose you see, this is the geometric distribution, right? If this is the geometric distribution, I can calculate the probability x greater or equal to 20, right? By the formula 1 minus 1 by 5. I mean, by the using the formula, right? 1 minus 1 by 5. I mean, 1 minus p raised to power k minus 1 into probability into p. Yes or no?
Sir,
Are
can you
you
repeat?
okay? So suppose I'm saying, okay, let me. I will take another example. Don't worry. Okay, let me explain some other thing. Okay, what if in this case, suppose what if I ask probability x greater than 12? Tell me what will be the value. Be careful. This is probability x greater than 12.
Just a second, sir.
It is 1 minus probability less than or equal to.
No, what's the need of do one
5 by 11. 5 by 11.
5 by 11? Why?
I'm writing in
Because
terms of
it
x
is
greater or equal
not
to 11.
equal to
5
12.
by 13.
5 by 13, right? Why 5 by 13? I think someone is saying
Greater than 12, so it would be equals to 13 and greater than 13. So
correct,
we are including from 13.
correct. I think someone was telling 5 by 11. I mean, that is by mistake. He is trying to do that one, right? This is okay, no problem. So basically, since if you see this inequality itself, okay, this x greater or equal to c is there, right? So this probability x is greater or equal to 12. So can I write probability x greater or equal to 30?
Yes, sir.
Yes or no?
Yes.
Are you getting? Because this inequality for x greater or equal to 3, right?
Yes, we can.
So this will be less or equal to 5 by 13.
Yes.
Is this all right?
Yes, sir.
Are you getting my point?
Yes, sir.
Yes, sir.
So,
Okay. Or else what you can do, probability x greater than 12 is there. So can I write 1 minus probability x less or equal to 12?
Yes, sir.
Yes, sir.
But what if in this case, because Markov inequality is defined for greater or equal to sign. Okay, let's do
Yeah,
in
we
the
don't know.
reverse order. No, you can do, it's not like that. Suppose I ask probability x less or equal to 10. Then tell me what will be there. So these things I can write 1 minus probability x greater than 10.
Yes.
Now I can write 1 minus probability x greater or equal to 11.
Yes.
Yes,
So
sir.
that means 1 minus 5 by 11.
Yes.
Okay. So this will be something, okay.
Sir.
Okay. This will be greater or less or equal to 5 by 11. This will be greater than.
Yeah, greater than or equal to.
Okay.
Sir, one doubt in this. How did you get 5? Because that it is geometric 1 by 5.
Yeah. We are talking about in terms of this one, this example itself.
Correct. But how the mean is 5? It is 1 by 5, right?
Okay, tell me, I'm saying X is following geometric distribution with probability P, then expectation is 1 by P, right?
Right.
Here P is itself 1 by 5.
Okay. It is
So
5. Okay.
1 by 1 by 5 will be 5. Understood?
Yes.
Okay, fine.
Sir,
Okay, so
for
basically,
x, sir, for x greater than a constant, we take the upper bound, and for x less than a constant, we get the lower bound, right?
lower bound, yeah.
Okay.
Okay, so thus just keep in mind this one, because this inequality is defined for greater or equal to sign. Okay, just keep in this mind. Okay, so if something is asked, suppose I'm saying find the probability that x will exceed 15. So I'm saying find probability that x will exceed 15. That means what you have to calculate?
X will be greater than 15.
X will be greater than 15, right? To use
Yes.
apply the Markov inequality, it should be probability x greater or equal to 16, right?
Yes.
Yes or no? Then it will be less or equal to, suppose the same geometry, it will be 5 by 16. Is this clear? Just be careful with this terminology. Okay, so Markov
Yes, sir,
inequality
clear.
is all right for everyone.
Yeah.
Okay, so I was talking
Sir,
about something
what about the
binomial.
lower bound?
Yeah,
What
this is
about the
this one case, right? This is the
okay, got it.
Examples you can give some for this, questions which of this kind of
sorry,
any
could you
kind
repeat?
of questions that would make use of this. Any kind of questions that would make use of, or any scenarios which would make use of this,
Markov inequality. Okay,
theory
okay.
of Markov.
Let me tell you. Actually, Markov inequality is helpful when we don't know about the distribution. Okay, what I mean, I don't know about distribution. Let me tell you one thing. Suppose I'm saying x is where is just give me
That does it mean that CDF and PDF none is known?
CDF and
PDF
yes,
is.
yeah. Okay, suppose I'm saying I'm saying simply I'm saying suppose x denotes the some you can say number of some number of item is produced in a factory. Sorry, I think the same example I took in the week 3 open session. Suppose this is the number of items, okay, is produced in a factory, okay, with mean, let's say with mean some 20 or let's say 40 and variance let's say 25, for example, just a dummy value. Okay, this is something. Then I ask what is the probability that for a particular week number of items will exceed let's say 75, for example. Then can you calculate the exact value here? No,
No.
Yeah, we can't.
we can't, right? Because we do not have any information about
Distribution.
distribution, right? So in this case, Markov inequality is helpful because it will give you some idea, some bound. Okay. So suppose this is case. Suppose I'm saying question is what is the probability that find the probability that production will production will be at least let's say 75. So what do you mean by at least 75? So you have to find probability x greater or equal to 75, right? So this will be less or equal to mu by c. So what is the mu? Is
40.
40, c is the
40 by
75.
75.
So here you will be having some idea about the probability. Now you can't calculate the exact probability. Are you getting that? If you don't have the information about your random variable distribution of random variables, then Markov inequality, Chebyshev inequality is very helpful to get the some idea about your probability. Let me change the scenario. Suppose I'm saying,
Sir, one doubt with
yeah,
the Markov's inequality, we can always calculate the range, at what range it will fall. What is the probability, right?
bound.
Yeah, bound. But we don't know whether it is upper bound or lower bound, right? That
No,
cannot.
it's upper bound, right?
So it is always upper bound.
Not about always. See, this is the greater. See, this is the lesser equal to sign, right?
Hmm.
So what? Okay, what is meaning of upper bound? Means this quantity will always be less than this value, right?
Correct.
So this is the upper bound, right?
Okay.
I mean, this is the upper bound, right? If something is less or equal to something, so this is the upper bound. What if lower bound you are talking about? Suppose I'm saying x is less than 74, for example. This means I can write 1 minus probability x greater or equal to 74. Yes or no?
Yeah, yeah, okay,
Yes,
okay.
sir.
We change the sign and then okay.
We
Okay,
can
okay.
change the sign, right? From here, it will be 1 minus. So this will be actually, if you see probability, only for probability x greater or equal to 74, it will be less or equal to 40 divided by 74.
Okay, so with Markov also the question can be upper bound and lower bound.
Lower bound.
both.
Okay. So the only thing you have to keep in your mind this form. Anyway, this form will be given to you in the question paper. You have to apply. That's all. Okay. Understood?
So that
Excuse me, sir.
Yeah, yeah.
Can we go for this at most case?
This is the at most, right? At
At
most
least.
is what? Yeah,
At,
this at least what? Bound or random variable?
at least random variables.
So this is the case at least random variable. The same thing I discussed, right?
At most, sir.
Okay, at
At
most
most
means
is
okay. Suppose
x.
I'm saying x is less or equal to 74. Okay,
Yes, sir.
then it will be x is greater than 74. You to keep in your mind just equal inequality. Then it will be x is greater or equal to 75, right? So
Yes,
for
sir.
this,
Yes,
you
sir.
can apply the Markov inequality. Okay. So here sign will change. Here it will be greater than, right? Because here it's a 1 minus less than something. Okay.
Got it, sir.
Got it?
Thank you.
Oh, fine. Suppose, let me give you just idea. Suppose I'm saying x is follows binomial 5 comma half, for example. Then I ask, what is the probability that x is greater or equal to 4, for example. Then by using the Markov, okay, first of all, I have information, this is the binomial, so I can calculate this probability or not.
Yes, sir, we
Right?
can.
From here, I can calculate the exact probability.
Yes.
Yes or no? Because I have the information about distribution. In the same scenario, probability x greater or equal to 4, if you will apply the Markov inequality, it will be less or equal to expectation of, what is the expectation of here? X 5 into half. That means 2.5, right? So 2.5 by 4, right? So this means what?
Yes.
Here I can calculate the exact probability. So the value which you will get by calculating this value, it will be, so this quantity always be less or equal to this value. You can calculate and you can cross check. Okay. So if you know the distribution, you can calculate the upper bound, you can calculate the exact probability also. I mean, it will depend on the question. But if you don't know the distribution, then you can't calculate the exact value, you can't calculate the exact probability. The in that case, you can calculate the bound itself. In that case, your this sorry, Markov inequality helpful. Is that clear?
Yes, sir.
Clear to all of you?
Yes, sir.
Yes,
Fine.
sir.
Now, let's move to the Chebyshev inequality. Okay. Actually, Chebyshev inequality is nothing but just an extension form of the Markov inequality. Okay. I think I'm not going in the derivation part because we have to cover the week 4 also. You can prefer the week 3 open session. I have done the derivation from where we got. I will just use the form and I will tell you in which scenario which form you have to use. Okay. So
Yes.
Chebyshev inequality, suppose x is the discrete random variable, okay, with expectation as a mu and variance as a sigma square. Then there are two forms. First one is probability that modulus of x minus mu greater or equal to k sigma, it will be less or equal to 1 by k square. Okay, now you will tell me what is this 1 by k square? Is this upper bound or lower bound?
Upper bound.
Upper bound.
Upper bound.
Upper bound, because this quantity will always be less than this one, right? And there is another form, second form is there. This is first form, this is second form. What second form tells us? Probability that x minus mu, okay, less than k sigma, sorry, greater or equal to 1 minus 1 by k square. What is this? This is
This is
lower
lower
bound.
bound.
Why we are saying lower bound? Because this quantity will exceed this one. I mean, this is the lower quantity for this probability of modulus of x minus mu less than k sigma will be greater than. Okay. So by using the same information, I mean this x is the number of items produced in a factory with mean 40 and variance. Okay. Suppose someone asks about variance also. So in Chebyshev inequality, this variance is useful actually. Okay. Let me tell you the scenario where you to use. Suppose let me do the first one. First derivation. So probability that modulus of x minus mu less or equal to k sigma, sorry, greater or equal to k sigma, okay, less or equal to 1 by k square. Okay. Now, so if this is the case, can I write probability this one? Okay, just tell me if you are getting the things or not. Can I write this one as x minus mu greater or equal to k sigma, or x minus mu less or equal to minus k sigma?
Yes, we can.
We can, right? Now, if this is the case, can I write probability x is greater or equal to mu plus k sigma, or x is less or equal to mu minus k sigma? Yes or no?
Yes.
I can write just a
Yes, sir.
transformation, right? So now you can use this case, this things when suppose I ask the question in the same scenario that x is number of produced. So this will be helpful. Suppose I ask what is the probability that number of items will be, let's say, at least 70 or at most 30, something like that. Okay. Are you
Yes, sir.
getting? Okay. I can change the scenario, right? If this is the case, okay, at least 70 or at most 30 for a particular week, something like that. I think, I mean, we can say at least, okay, okay, 1 minute. Let me take some example from activity. Just give me a second. Okay. It's already 9:20. Okay. So let me share my screen with some different example. Okay. So can you see this question? Question number third.
Yes, sir.
Okay. Now in this question, it is asking, suppose a fair coin is flipped 200 times, right? Find an upper bound. Forget about this upper bound. What is the probability number of items the coins lands on heads is at least 130, at most 70. Okay. So what is saying? Okay. So if this is the coin, that means it will follow binomial 200 comma half, right?
Right.
Then what will be the
Yes.
expectation of x? That
100.
means
NP 100.
p, that means 100, 200 by 2, correct?
Yes.
Mm-hmm.
And what will be the variance? NPQ, I mean NP1
Yes.
minus p, that means 100 by 2, which is again 50, right?
50.
So what questions asked here? If you see, just need, we have to be careful with the statement. Probability that at least 130, at most 70, that means, sorry, probability that at least 130, right? Or at most
Yes.
70, right? So is this form same as this one?
Yes, sir.
Yes or no? Can you
Yes.
see the inequality are same? That means we have to calculate the less or equal to 1 by k square. So we have to find the value of k. Yes or no?
Yes.
Everyone is getting, I think Radha, Biplav and all, those who had doubt,
Yes. Yes.
right? So that means this mu
Yes, sir.
plus k sigma, I can equate to 130.
So it is saying at least 130, at least 70, right?
At most.
At most 70. Okay, okay.
Okay. At most means it cannot exceed 70. Okay. So mu plus k sigma is 130. So what is the mu here? 100 plus k. What is the sigma? Sigma will be square
Under
root of
root
50. Right? Let's take it square
Yes,
root
sir.
of 50 itself, which is nothing but 130. So k times square root of 50 will be 130 minus 100, which is 30. So k is what? 30 divided by square root of 50. So what we have to do,
Yes.
just substitute the value of here. So it will be probability x greater or equal to 130 or x is lesser or equal to 70, lesser or equal to 1 by 900 divided by 50. So it will be lesser or equal to 50 divided by 900, which is something 1 by 18. Let's say, so 1 by 18 should be the correct answer. Yeah, so 1 by 18 is the correct answer. Now, is this clear? Which form you have to use? The
Yes, sir.
first
This is
form.
clear.
Is this clear? Clear to all of you?
Yes.
Okay.
So in the question, it asked for the upper bound, right?
Yeah. So you can see we have calculated the upper bound itself. It's a less or equal to, right? This is the upper bound. See, upper bound means this quantity should not exceed this value, right? So this is the upper case, right? This is the upper value, right? This is the at most value.
Can you please go back to the question once, just once question. I mean, what is it? The finally what it was asking, inequality, at least this and okay.
Okay, so this is at least 130 or at most 70. The same thing I have written. At least 130 or at most 70. That means if
So,
you see this form we have to use, right?
so here in the question, it is specifically asking find the upper bound, right? But
Okay.
there will be some time it will not
It
say
will not
whether
mention, yeah. It may be case there is not, there, I mean, it is not mentioned that which bound is there. But if okay, suppose you have identified this one, right? It means you have to find the upper bound. Clear?
okay, if question is not saying anything, then by default you should go for upper bound.
No. See, not by default you have to go upper bound. Thing is that what is the statement of the question? See, by this quantity, right? X minus mu greater or equal to k sigma, I came to this final step, right?
Correct.
Right? Forget about this. So what this is? So x is at least mu plus k sigma, or x is at most mu minus k sigma, right? That is something we are finding, right? So in this case, what question tells us? In this case, question is saying what is the probability that x is at most 130 or x is at least 70, right? So that means this is the form, right? This means we have to calculate the upper bound only here, because this is the case. This is the or case, right? At least at most. Are you getting?
Yes.
Is clear? Now come to the second form. Now that will be helpful. That will give you some idea. This case, second form. So second form, what is the second form says? Probability that modulus of x minus mu less than k sigma greater or equal to 1 minus 1 by k. See, don't memorize the upper bound and lower bound. One form will be given to you. Another form you can simply help. Okay. If you will see this case, what if this case? I can write this one as minus k sigma less than x minus mu less than k sigma. Yes or no?
Yes, sir.
The only thing you have to do, you have to just solve the inequality after this p. Okay. So if this is the case, what I can write? I can write mu minus k sigma less than x less than mu plus k sigma or not? Yes or no?
Yes, sir. We can.
I can.
Yes.
Correct. So if there is any question which is asking about find the probability that your x is between, let's say, 40 and 60, then can I use this form? Yes or no?
Yes, sir. We can.
Right? That means I have to find the upper bound. Yes or no?
Yes.
Lower.
Sorry, lower bound. Yeah, thanks for the correction. Is this clear? The thing
Okay.
you have to keep in mind see here in this case it is asking about between, right? X is lying between 40 and 60, while in the above case it was X is at least something or at most something. Is
Yeah,
this clear?
understood. Yes,
Is this
now
clear
it's
to all
very
of you?
clear.
The only thing is you have to keep just expand this quantity. You will get the idea. See, if you got the question right, just take the Sevier inequality, just expand the quantity. You will get the idea. If is this or, right? In the question it's also mentioned or. Just simply use this form, or it's mentioned like in between. Then you have to use this form. That's all. Is this clear? Any doubt?
No, sir, no doubt. Clear.
Clear for all of you?
Yes.
Okay. Yeah. Great. Okay. So just okay. Then let's. I think we have some half an hour. No problem. Let's move to the week 4 content. Okay. So what are the topics in week 4? It's nothing but, I mean, we are moving basically to the continuous word. Okay. So to understand the continuous things, let's move. Actually, for the continuous, we are going with the uh, probability itself. Actually, sorry, PMF itself, discrete kind of thing. Okay. Suppose I'm saying X is following some distribution. Okay. Let's say. Okay, first of all, let's discuss the what is the CDF at all. Okay, what is the CDF? Okay, so full form of CDF is cumulative distribution function. Okay, so what is the CDF is does actually? Okay, suppose I have discrete random variable. Okay, which is defined as let's say with probability mass function. Some, let's say I'm saying X is taking values x1, x2, xn. Okay. Then probability x equal to x is, let's say, p1, p2 up to pn. Okay, this is the something. So CDF is nothing but called cumulative distribution function. So by the name nomenclature, if you say cumulative, so what CDF does, basically it accumulates double C accumulates the probabilities, accumulates all the probabilities till a point. Okay, means suppose, okay, in this case suppose I ask probability x equal to x3, you can simply tell me p3, right?
Yes.
If I will ask probability x equal to x2, you will simply tell me p2, right? What if I will ask probability x lesser equal to x3?
You have to add all.
x1 plus
Plus
x2 plus
P3.
x3.
So that is the something CDF defines, means it accumulates all the probability till a point. So till this point, suppose this is the x3, that means we have to accumulate all the probability x equal to x1 plus probability x equal to x2 plus probability x equal to x3. So that means it will be p1 plus p2 plus p3. So that is something your CDF is defined. Okay. Now I will be moving. Suppose, let me take one example. Suppose I'm saying X is following uniform distribution. Okay. Let's say 0, 1, 2 up to 50, for example. Okay. Now I'm saying. Now tell me, what is probability X equal to 0?
1 by 50.
1 by 50?
51.
No, 1 by 51.
Correct. What if probability X equal to 1?
1 by 51.
Same. Probability X equal to 50? 1 by
1 by
51.
51.
1 by
Now,
51.
what if I will ask probability X lesser equal to 2?
3 by 51.
Less or equal to 2.
3
That
by
means we have to
3 by
accumulate all the
51.
probability plus.
3 by 51.
Okay. So it will be 3 by 51. Is this clear?
Yes, sir.
1 by 51 for this one. Okay. What if probability x less than 2?
So 2 by
2 by
51.
51.
That means probability x equal to 0 plus probability x equal to 1 only, right? Because it's a discrete, right? Very good.
Yes.
Okay. Tell me, what if probability x lesser equal to 20?
And from 0 to
21 by
21.
51.
21 by 51.
right? That means 21 by 51. Okay. Now tell me, probability x less or equal to 20.5.
21 by
That's
50.
only
21 by
21 by
51.
That means it's a should be x less or equal to 20 plus probability x equal to something at it will be 0, right? Basically, it will be 21 divided by 51. Yes or
Yes.
no? So there is
Yes, sir.
one property which okay. So there is properties for CDF. What is called fx of x is a non-decreasing function. Okay. What do you mean by non-decreasing function? If you see here, non-decreasing means either it will be constant, right? Either it will be constant or it will increase, right? You can say here, right? Either it is constant or it will increase. Yes or no?
Yes, sir.
Correct. Another property is if x1 any value is less than x2, then CDF, actually CDF we are defining, denoting as capital F, x1 less than f of x2. As you can see in the previous case, so what is the x? Okay, so you can see 2 is less than 20, right?
Yes, sir.
And we have seen f of 2 is also less than f of 20, right?
Yes.
Okay, this is the property. Okay, another property is range of CDF is what is that? Since it's a function of it's a probability actually, so range of CDF is 0 to 1. Okay, is that all right?
Yes.
Okay.
Yes, sir.
Now, okay, why? Okay, let me just tell you. We had x uniform 0, 1 up to 50. Okay, what if I will ask probability x less or equal to 50?
It's 1.
51 by
It's a 1, right? Basically, we have to
Yes.
add all the probability till 50, right?
Yes, sir.
It's a 51 divided by 50, which is 1. What if probability x less or equal to 51?
It's 1 again.
So basically, I can write x is less or equal to 50 plus probability x equal to 51. So it will be 1 plus for this probability, it's a 0, right?
Yes, sir.
What if x less or equal to 59?
Same 1.
Same one, right? That means x less or equal to 50 plus all will be 0, right? So I will get 1, right?
Yes.
So can I say as x is tending to infinity, f of x plus infinity equal to 1?
Yes, we can say.
I can say. Okay. In the
Yes, sir.
same scenario, tell me what if probability x less or equal to -1?
0.
0.
0? Everyone is getting point, right?
Yes, sir.
What is probability x less or equal to -50?
Still 0.
Still 0. Probability x less or equal to -250?
0.
0. So can I say if x is tending to minus infinity, fx of minus infinity will be 0?
Yes, we can say.
I can say, right? I mean, it's not exactly, it's a tending to 1 actually. Okay, by mathematically, it should be tending to 0. Now, okay, so there are some properties which you can keep in your mind because it's helpful. Okay, so what if probability A less than x less or equal to B? Okay, for this case, can I write this same as probability? Okay, let me draw one thing. Maybe that will give you idea. Suppose this is the A. I'm saying A is x is somewhat here and B. So I'm asking what is the probability of A less than x less than B? Sorry, less or equal to B. That means less than A means we have to see this red region before A, right? Because it's a
Yes, sir.
discrete, right? And I'm asking less or equal to B. I mean, sorry, sorry. Actually, I'm interested in A, sorry, this x is after A, right? And till B, right? This green one, right?
Yes, sir. Above A less than B.
Okay. So how I can find this green? If I will subtract the red one, okay, from this blue one,
Yes, sir.
yes or no? If I will subtract this red one from the blue one, I will get the green one or not?
Yes, we
Yes,
will.
sir.
So that means x less or equal to b minus probability x less or equal to a. See, here x is after a, that means we have to consider till a, right? We have to subtract the red region till a, right? Yes or no?
Yes, sir.
Okay, so this means I can simply say fx of b minus fx of a, right? Would you
Yes,
agree?
we can
Are
say.
you are you getting my point, right?
Yes, sir.
Yes, sir.
Okay, so yeah, just give me a second.
Sir, why won't we take a plus 1?
Why don't take a plus one?
I mean
Okay,
probability,
then you have to write a plus 1 less or equal to. Both are the same thing. Okay.
because we are not including a in the range from a to b. So probability
You
that
can
x will.
see, we are not denying. You can write. It's not okay. Okay, so just I'm trying to explain here the funda here. Okay, so same thing. If I will write probability, tell me a less or equal to x. Let's see. Till now we are in discrete case. Okay, this is a less or equal to x less or equal to b. So can I write this as probability a less than x less or equal to b plus probability x equal to a? Yes or no?
Yes, sir, we
Correct.
can write.
Yes, sir.
Since we have this information, I can simply put the value, right? What if, tell me, probability A less than X less than B? You have this quantity. So can I write probability A less than X less or equal to B minus probability X equal to B?
Yes,
Yes,
sir.
we can write.
Right?
Yes, sir.
Same, if I will ask probability A X or sorry less or equal to X less than B. So just write what you have. I have probability A less than X less or equal to B. That means I have to add probability X equal to A, right?
Yes.
That's
And
all.
subtract probability x equal to b.
And subtract probability x equal to b.
Yes.
I think it's the correct one, right? Or no, no, no.
Here
Okay,
we
We
yeah,
need
need
to
okay.
we
instead of
need to.
x
But
and
okay, okay. What we can do in either another way. I can write this one or not. Tell me now.
Yes, sir, we can write this.
We can,
Yeah,
right?
we can
So
write.
we can just substitute the value. So this is for the discrete case. Okay. Okay. Tell me the same information. X is following uniform 0 up to 50. Okay. Tell me. Okay. You have the pen and paper. Just tell me what will be the value for this.
2/51, sir.
2 by 51. Okay. Let's do. So this is something I can write probability x less or equal to 5 minus f, sorry, probability x less or equal to 3, right? That is I can write fx of 5 minus fx of 3, basically. So what is this? This will become 6 by 51 minus this will become 4 by 51, which is nothing but 2 by 51. Yes or no?
Yes,
Sir,
sir.
why we are taking x less than equal to 3? I
The same thing I have done just a few seconds before. Just want to
I
explain
didn't.
this formula.
Okay, so it is same as
This is
taking
same as right. Instead of A, I have 3. Instead of B, I have 5.
no,
A
no.
less
I
than X.
mean a less than x, a absolutely less than x is
Hmm.
same as a less than equal to x. Can we say that when we are doing cumulative function?
See, it's not like that. See, here I'm saying probability that A less than X less or equal to B, it will be equal to probability X less or equal to B minus probability X less or equal to A. Okay. See, our interest region of the interest is this green one, right? To calculate the green one, what I will do, I can subtract from the blue minus red, right? So what is blue? Blue is X less or equal to B, right? Minus,
Yes,
if
sir.
I will subtract A, then I will get the this quantity. Okay, so this is the formula one. Okay, fine.
Yes, sir.
Sir,
Okay,
Understood.
so yeah, go
what
ahead.
is the difference between capital F of x and small f of x?
Sorry, could you repeat?
Sir, what is the difference between capital F of X and small f of X?
See,
This is
small.
little confusing.
No, it's not confusion. Let me clarify. Fx means capital F. It denotes the CDF, cumulative distribution function. Okay. Small f, it will denote your PMF, probability mass function, or PDF for continuous. Okay.
Okay, sir.
Okay. So here itself, see, there are two approaches. You can do like this for discrete case, but see, this property is helpful. Another approach is it is asking.
So this small thing, how 6 by 51 came, sir? By fix of 5, it should be 5 by 51. No?
No. It's from 0 to 50.
Oh, 0 to 50.
Okay. So for this case, I can also write probability x equal to 4 plus probability x equal to 5. Yes or no? I mean, x is more
Yes,
than
sir.
3 but less than 5. So I can simply say here 1 by 51 plus 1 by 51, which is 2 by 51. In either way, you will get the same answer. Okay. But this property
Yes,
you can keep in your mind because it will be helpful for continuous random variable. Okay.
Sir, can you scroll down a bit?
Discreteness, sir.
A little more.
Okay.
Where you have written those three things. Yes, sir. This.
Sir, this is valid for only discrete random variable, na?
Yes.
Thank you, sir.
In case of continuous, this inequality and all doesn't matter. I will tell you by its case. Okay. Now,
Sir, I have a small doubt. Like when the given is piecewise function, when the from solving the question, when have to integrate this function or when use the directly the function, sir?
when to use integrate? See, if it's asking about some probability, right? Some range. Okay. Then you have to integrate. Okay. Okay. Just wait for a minute. I will come to that point. Okay. Let me.
Okay.
Okay. Don't worry. Okay.
Sir,
So for this,
sir, if it ask given PMF, if given range is there, that time you have to do integrate, right? Integration.
not PMF, PDF, right?
Sorry, PDF.
PDF. I will discuss that point. No, don't worry. Okay. Okay, so
Now
why
we-
we are moving to this? Okay, let me do one CDF part itself. Okay, for this CDF case, how will you plot the CDF? Okay, basically. So in on the x-axis, we are denoting the values. On the y-axis, it will be the basically CDF value. Okay. For example, suppose this is the 0. Okay. Then 1. Okay. Then 2. Then 3. Then 4 up to 15. Okay. So for 0, suppose this is the 1 by 51. Okay. Okay. For 1, this will be 2 by 51. Yes or no? For 3, it will be 3 by 51. Then 4 by 51. Then up to 1. Okay. So for 0, how will you plot probability x less than 0, x less or equal to 0? So what will the CDF? Like this? Okay. Yes or no?
Yes, sir.
On a
So
CDF plot, because
broken step,
right?
so broken
For
step.
one, it will be like this. For 2, it will be from 351. Okay.
Yes, sir.
Are you getting what I'm trying to do, what I'm
Yes, sir, getting.
doing? Okay. So for 50, it will be 1 onwards, right? Is this clear somewhat? Okay.
Yes, sir.
So basically,
sir.
what is the case? Suppose I ask probability x less or equal to 0. That means probability x equal to 0 because there is no value before 0. That means 1 by 51, right?
Yes.
Yes or
Yes,
no?
sir.
Right. What if probability x less or equal to 1? That means probability x is 0 plus probability x equal to 1, which is 2 by 51, right?
Yes, sir.
Okay.
Yes, sir.
So what is probability x is less or equal to 2? It's a 3 by 51. Okay.
Yes, sir.
Now, one more thing, tell me, if so this is the CDF plot. Okay. If I will ask the probability at a single point, so that jump is explained so this jump, okay, every jump will give you the probability. This is the probability x equal to 1. This is the probability at x equal to 2. This jump is probability x equal to 3, actually. Are you getting? Because probability x equal to 1 is what? Can I write this probability x equal to 1 as a probability x is less or equal to 1 minus probability x less or equal to 0 or not?
Yes, sir, we can.
So 2 by 51 minus 1 by 51 will give you 1 by 51. Okay.
Yes.
So in case of discrete, we will be having the jump. Okay. Is this clear?
Yes, sir,
Yes,
clear.
sir.
Okay. Now, okay. So let me move in the terms of continuous word something. Okay. So suppose I'm saying, okay, suppose let's just try to understand the continuous random variable. Okay. Suppose I'm saying I have binomial distribution. Suppose my random variable x is, okay, defined as binomial random variable with let's say some any value we can say for us. Let's take 1,000 or 10,000 something for our uh, something.
Sir, what are the distributions we will be considering for continuous?
Normal, exponential, uniform, and all.
Okay.
Okay, so suppose this is I'm saying x is follows binomial 10, 5. So suppose I will ask probability x equal to 3. Then you can simply tell me what is the how will you calculate this one? Right? You can simply tell me 10c3 half raised power 10, right?
Yes.
Okay, you will tell me some value. Let's say it's a p1. Suppose I ask probability x less or equal to 4. Then you can simply calculate probability x equal to 0 plus up to probability x equal to 4 and you will tell me the value, right? What if
Yes, sir.
this is very large? Suppose n is something 10,000 in case, okay? Then probability x is less or equal to, tell me some less or equal to 1,000, okay? So will you do probability x equal to 0 plus 1 plus 1 plus up to 10,000 or would you, I mean that is something in today's world you can do, right? You can find the but by the computer and all, but it's very tedious task, right? Okay.
Yes, sir.
So actually in this case when your n is very large, right? So we are moving to the continuous word. Continuous word means we are okay. So in this case what we'll do, rather than adding the continuous summation, rather than doing the continuous summation, we are okay with some error. Okay, we'll see some approx thing, but we it will be more good if you are calculating the approximate thing rather than doing the, okay, because why it happens, let me tell you that uniform case itself. Okay, okay, let's move to the, okay, somewhat you are getting the idea what I'm trying to explain, why we are moving to the
Yes,
continuous. Yes or no?
Yes, sir.
Okay, so in case of discrete uniform, let's continue with that example itself. So in case of discrete uniform, what you have seen, suppose x is following uniform 0 to 10. Okay, then what kind of our CDF graph will look like? It will look like, suppose this is the x, this is the fx, right? So this is the 0, 1, 2 up to 10. So this will be 1 by 10, then 2 by 10, right? Then 3 by 10, not 10, it will be 11, sorry, up to 1. So for 0, it will be graph, graph will look like this, right? Yes or no?
Yes, sir.
Right?
Yes.
Correct? Now,
Yes, sir.
what if, suppose in the same scenario, suppose I'm saying x is follows uniform 0 up to 10,000. Okay, then how your graph will look like? So my graph will look like, suppose this is x, this is fxx. So it's about
Points
0,
closure.
1, 2, 3, something like that, up to something 10,000, right? So it will be like this, right? So it will be 1 by 10,000 1, right? Then
Yes,
2
sir.
by 10,000 1, right? Then 3 by 10,000. I mean your graph will be like this, right? Very, very, very. I mean their jump will be finished, right? Something. Basically, are you getting my point? What I'm trying to explain?
Yes, sir.
Okay.
Yes,
So
sir.
basically, it will be like this. So your jump will not be there. Okay. So in case of discrete, you will get jump, right, at this point. But if n is very large, you are not going to get a jump. Okay. So that is something continuous random variable. Okay. We are moving to the continuous random variable. If this, okay. If suppose I will ask what is the probability x equal to 1, you can simply tell me 1 by 11, right? By calculating the jump, right? In this case,
Yes, sir.
if I will ask, tell me probability x equal to 4, can you tell me? It's a 0, right? Because there is no
Yeah,
jump.
almost 0.
Yeah, there is no jump, right? Are you getting my point?
Yes, sir.
Is this clear? So
Yes,
basically,
sir, it is.
how we are moving? So I had discrete random variable. In discrete random variables, we have done PMF of that random variable. Okay. After PMF, we move to the CDF, right? Yes or no? Then this will, after this, we are moving to the continuous random variable with the help of this CDF. Okay. And this is the something we will get the CDF of continuous random variable and then PDF of continuous random. Okay. So basically, this is the bridge. CDF it creates a bridge. Okay, this is the bridge. This CDF is a bridge between discrete to continuous. So some rough idea is okay.
Yes,
Yes,
sir.
no, yes, no. Are you getting my point, right?
Yes, yes.
Yes, sir.
Fine. So basically, this CDF has no jump. So I will say some properties and all. So if this FX has no jump, right? Okay. If it's a continuous case, if it has no jump, then I will say probability at a single point it will be 0, right?
Yes.
And we have seen in case of discrete probability A less than X less or equal to B, we have seen fx of B minus fx of A, right? See, this is the very important you can keep in your mind. So what if probability A less than or equal to X less than or equal to B? So we have seen probability X less or equal to B minus probability X less or equal to A. We have added probability X equal to A, right?
Yes.
But it's a continuous case, then it will be 0. Again, it will be same. Okay. So in case of continuous, you can see equality in doesn't matter. When if you write A less than X less than B, it will be same. Okay.
Yes,
Are you
sir.
getting? Because this that probability at a single point will be 0, right?
Yes, sir.
Okay. Again, it will be fx of B minus fx of A. Actually, this fx of B nothing but probability x less or equal to B, and this is probability x less or equal to A. So this one is the very important for case of continuous. I mean, you can simply write fx of B minus fx of A. So there is a one question related to this in the solve with us PDF of week 4. Okay. So you can prefer that. Okay. So it's a uh, kind of hint or suggestion. Just go through once, solve this PDF of week 3 and week 4. Okay. You just
Okay,
solve
sir.
the questions again. It will give you some rough some idea to solve the questions. Okay. Okay, so it's kind
Okay,
of
sir.
important. Okay, just after the session you can go, because these are concepts you can cover, and there will be questions in quiz one related to these concepts. Okay, that is a hint from my end. Okay, now what is the continuous random variable? What are the examples? Anyone? I mean something weight of person, right?
Time period of batteries.
Yeah, basically, yeah, lifetime of a battery. Okay, so this is something it happens in case of continuous, right? So basically speed of vehicle, right? Yes or no?
Height of a person.
Height of a person, yeah. Weight, height. Okay. Amount of milk, right?
Yes, sir.
Okay. So basically continuous and all, it's something which we have to measure. We cannot count. Okay. Now let me give you some one rough one thing. Suppose I have this kind of graph. Okay. I have suppose any kind of function is there. Suppose I have this function. Okay, this is my function. Okay, a function is there. Okay, I will tell you what I'm trying to explain here. Suppose I'm saying one x naught is there. Okay, then this red region, this shaded one, I will say this is fx naught, capital Fx naught, means This is probability x less or equal to x naught. Yes or no?
Yes, we can.
We can say, right? Now, suppose I'm saying this is the a minus delta and this one is the a plus delta. Okay. I want the region of, I want to find the probability that a minus delta less than x less than a plus delta. So what we have to do?
Integrate.
We have to integrate, but how you know we have to integrate? Basically, what we have to do, if the, okay, suppose in just in a scenario, basically just make a small strip, okay, just this, I mean this very small gap, I mean basically. So what we have to do, okay, suppose this blue, all the blue lines, okay, just assume there is very less gap, okay, in every blue lines, okay. So can I do, so basically what we are doing, we have to add we have to do continuous summation, yes or no, right?
Yes, sir.
We have to do continuous summation basically. So continuous summation is nothing but integration, okay. So this means we have to do a minus delta to a plus delta, which one? Fx of x with dx. So basically this dx is nothing but that, I mean, how I'm going in that mathematics part.
Weight from that strips.
Yeah, that is true. Okay, so basically that is something. So basically this is something defined as like this. Okay. Okay, this is
Yes, sir.
this one is okay for everyone. Okay.
Yes, sir.
Okay. So the same thing is in case of
Why
discrete.
the diagram, sir? I just want to see the diagram.
Yeah. Is this clear?
Yes, sir.
Okay. So suppose x is tending to infinity, that means I will say fx of plus infinity will be 1. I mean the same thing we have seen in case of uh, discrete itself. Okay. Suppose I ask fx of minus infinity, that means what? Sorry, fx of plus infinity.
The whole graph.
That means I have to integrate. Okay, what is meaning this? This means probability x less or equal to plus infinity. Infinity means
Yes.
maximum. That means we have to integrate from minus infinity to plus infinity the PDF, which is nothing but 1. Actually, in case of
Yes.
discrete, if you see, summation of all the probabilities should be equal to 1, right?
Yes, sir.
Okay. So in case of this continuous, integration throughout the range will be equal to 1. Okay. Okay, so basically f of x is defined as probability capital X less or equal to x, with a small x is the one of the value. So how will you define? This is nothing but minus infinity to x. Let's make it x naught. So x naught we have to integrate the PDF like this in case, right? Suppose this is the x naught, then fx naught will be f capital Fx x naught will be minus infinity to x naught fx of x dx. Okay, is this clear? Any doubt?
Yes, sir. Clear.
Clear for everyone? Yes, no?
Clear,
Yes,
sir.
sir. Clear.
Okay, fine. So in case of discrete, we have seen, suppose I have PMF, probability mass function, then what are the properties? P should be greater or equal to 0, and second one is summation of all the probabilities should be equal to 1, right? The same
Yes, sir.
properties hold for PDF. So full form for PDF is probability density function. Okay. So this is nothing but this is the function from basically your R to R. Okay. And it should be the valid density function only if f of x is greater or equal to 0. Second one is integration throughout the range. Minus infinity to plus infinity means throughout the range. Fx dx should be equal to 1. Okay. And
Yes.
third one is this fx is the piecewise continuous. Okay. Okay, so what do you mean by piecewise continuous? Suppose I have function. Okay, piecewise continuous means I have function. Let's say I'm saying, let's say it is x cube something, and it is defined in a1, a2 between, then x cube plus 2, and it has been defined between, let's say a3 to a4, something like that, and so on some value. So it should be piecewise continuous means it should be continuous for this range, should be continuous for this range. That is the something. I mean, for each support is should be defined. Okay. So in case of discrete, we are saying range of a random variable. While in case of continuous, we are saying instead of range, we are saying support of random variable in case of continuous. So what is the support of any random variable is defined as the values of x such that your PDF should be strictly greater than 0 for that support. Okay. So somewhat idea.
Can you again explain this, sir?
Okay, so support of x is nothing but the value x such that PDF should be strictly greater than 0. Okay. That is something support of x.
Okay.
Okay. I mean, see, in case of discrete, what we are saying, x is taking the see range of x means what? Suppose x is taking value 1, 2, 3, and so on, right? In case
Yes,
of
sir.
continuous, rather than saying range, we are naming as the support of random variable.
Okay, understood.
Okay. Now, okay. So let me give you one question to all of you. Everyone has pen and paper.
Sir, that f of x is always greater than 0, right?
Ha.
Okay, so how it is, I mean, how we are saying support, because it is anyway greater than 0 all the time.
No. See. Support. How will you define support of x actually? So support of x is will be those value or set of those value or interval when fx is strictly greater than 0. Okay. For suppose for some case your fx is going to be less than 0. For example, suppose, okay, then that will not come under the your support of x. Are you getting my point?
Okay.
Yeah. Suppose fx is defined as for this region 0 to 1 and it will take value 0 otherwise. Okay, I'm saying this one. Okay. So my two questions. Okay, tell me what is the support of x here?
0 to 1.
0 to?
Greater than 0, less than 1.
No, it's a open interval actually.
Open, sir, not included.
If you include 0, then support of x will be 0, right? Okay.
Yes, not
now tell
included.
me the very first question whether it's a valid or not.
Yes, sir, it is valid.
It is valid.
How will you check? Just tell me.
It is 0 to 1. If we do integration, it is giving 1.
It is giving 1?
Yes.
Can we cross check?
Yes.
Okay, let's
sir,
do. So what we have to do, we have to integrate minus infinity to plus infinity. Fx of dx should be equal to 1 to proof of valid PDF. So minus infinity to infinity means throughout the range. So range is 0 to 1 and we have 4x cube dx, right? Let's do 4 0 to 1 x cube dx. Okay. So it will be 4 and x cube dx is nothing but x raised to power 4 divided by 4 0 to 1, right? Everyone is aware about this. X raised to power n dx is nothing
Yes,
but
sir.
x raised to power n plus 1 divided by n plus 1. So now it will be 4 will get cancelled out and it will be 1 by 4 minus 0 is power which is nothing but 4. So it's the valid PDF. So in the same case, suppose I ask fx is okay, rather this, tell me what is the probability x less than half. Tell me this value. You can take some 1 and 2 minutes.
Probability of x less than half. So we have to integrate from 0 to half.
Correct. Just tell, just let's.
1 by 16.
Okay, let's do. Okay, so basically what we have to do, we have to, since range is 0 to 1, right, lower limit. So here we have to integrate from 0 to half because it's asking about probability till half. So we have to integrate these things, right? So this is something we are calculating. So 0 to half 4x cube dx, right? Very simple thing. So 4 into x is for 4 divided by 4 0 to half. So 1 4 will get cancelled out. So it's nothing but 1 by 2 raised power 4 minus 0 which is nothing but 1 by 16. Is this clear?
Yes, sir.
Okay. Now just with the same function, can you calculate probability x less than half given that x less than 3 by 4? You can take some 2 to 3 minutes.
Yes, sir. We
Or yeah.
Hello, sir.
Okay. So this one, the numerator will be integration from half 3 by 4 to half.
No, no, no.
And,
Don't just assume. Just think whether are you doing
no,
right.
and I mean, I think I, and so it is 0.5 and it is point, so it is 0.30, so 7. Yeah, I think I get it. So what you have to do is the lower limit is 3 to 4 and upper is half. The numerator and denominator you have to take. So only integrate from 0 to 3, 0 to 3, 3 by 4.
1/81.
I don't know answer actually. Okay. So you are saying what about numerator part?
Numerator part, yeah, half
0
to
to
3
half
by.
integration.
So okay, I think Biplo, right? You are
0 to
saying
half.
numerator part we have to integrate from half to 3 by 4, right?
Yeah, yeah.
Let's see. Let's see. Okay.
No,
Okay.
0 to half for the
Sir,
Yeah.
0 to
Okay.
0
So
to
okay,
1/2.
1 minute. Probability A given B is what? Probability A intersection B divided by probability of B, right? So if you see probability x less than half, given that x less than 3 by 4, that means probability x less than half intersection x less than 3 by 4. Intersection means and, right?
Yes.
Divide by probability x less than 3 by 4, right? This is something we have to do. So far, so good.
Good.
Now,
Yes, sir.
so what is the limit of x? It's from 0 to 1, right? Suppose half will be somewhat here and 3 by 4 will be somewhat here, right?
Correct.
So what we are asking, x less than half.
Less than half
That
and less
means
than 3 by
x
4.
less than, that means this green region,
0 to 1/2.
and x less than uh,
3 by 4.
3 by 4. That means this orange region.
Mm-hmm.
Okay. So what's the common for this?
Okay, 0 to 3 by 4. I told the wrong
0
limit.
to 1/2, sir.
Okay. So common is this only, this from here to here, right?
Mm.
So this 0 to half. So what we have to do? Probability x less than half divided by probability x less than 3 by 4. Is this clear? So be careful little bit. You can simply draw a thing. So what you have to do here? You have to integrate 0 to half. Your PDF, I'm not going to derive, I think. Then 0 to 3 by 4, 4x cube dx. Is this clear how to do the thing?
Mm-hmm.
Is that all right for everyone? Okay. Okay, so
Yes, sir.
suppose for a question I'm saying uh okay, tell me fx of x is defined as something, let's say 4 e raised power minus 4x, okay, where x is greater or equal to 0 and 0 otherwise. Okay, now what is fx of x?
So PDF is given, and
Integration
Tell me
0
what
to
will be the
1.
probability x less or equal to x, means CDF of x.
Okay, CDF of x.
Integration 0 to infinity.
Yeah, integration 0 to x.
0 to, yes, that is correct. 0 to x integration of that f of x.
0 to x, right?
Yes.
So 4 into e raised to minus 4. Actually, this is the form of, okay, this is the form of exponential distribution. It's a lambda e raised to minus lambda x actually. So CDF of exponential is defined as 1 minus e raised to minus lambda x. Okay, if you will get the same thing, let's do this. So e raised to minus 4x divided by minus 4, 0 to x, right?
Correct.
So it will be minus e raised to minus 4x minus e raised to minus 0, right?
Right.
So it will be e raised for minus e raised for minus 4x plus e raised for minus 0. So it will be 1 minus e raised for minus 4x. Yes or no? So since you know the CDF, you can directly apply. First of all, CDF will be given. Okay, suppose I ask probability that tell me 2 less than x less than 3. Then what will be, how will you calculate? So there are two approach. First one, you can integrate the things from 2 to 3, 4 e raised power minus 4x dx, right? Yes or no?
Correct.
Or what you can do, I know probability a less than x less than b is nothing but fx of b minus fx of a. right?
Right.
So if this is the case, I can write probability. This is the case, I can write fx of 3 minus fx of 2, right?
Right.
And if you know here, I have calculated fx of x e raised to power 1 minus e raised to power minus 4x, right? So when I write 1 minus e raised to power minus 4 into 3 minus 1 minus e raised to power minus 4 into 2, yes or no? So it will be 1 minus e raised to power minus 12 minus 1 plus e raised to power minus 8. So I will get e raised to power minus 8 minus e raised to power minus 12. So what was the point here? You can do the integration also. Suppose you don't know the integration or you are getting difficulty to do the integration and you know the CDF form, then by using this property, you can directly do or not?
Yes, sir. We can.
Yes or no?
Sir,
Correct? Yes.
sir, can you scroll down a little bit? I have a doubt in the previous question. Sir, little bit more.
Where?
In the previous one.
This one?
Yes, sir, this one. Sir, it should be less than. Okay, sir. Thank you, sir.
Got it? Yeah.
Yes,
Now,
sir,
one
got it.
more question to all of you. One more question to all of you right now. By using the same concept, exponential, tell me probability that minus 3 less than x less than 5. What will be this? By using the CDF property.
Integration 0 to 5, sir.
Integration is 0 to 5 because CDF is defined, sorry, PDF is defined from greater or equal to 0 itself, right? Or else can I do fx of 5 minus fx of minus 3?
Yes, we
Yes
can.
or no? We can, right? We know x is greater or equal to 0, so this will be 0, right?
Yes, sir. This will go 0.
Because range is defined after 0 itself, right? So we have to
Yes,
do
sir.
only for this. So we know 1 minus series for minus 4 times 5. So 1 minus series for minus 20 will be the answer. Is this clear? See, here I wanted to explain the sorry, property of CD. Is this clear?
Yes, this is
Sir,
clear,
in
sir.
exponential case,
Hmm.
if we go by integration, sir, above question, previous answer.
Huh?
If we some of more previous, sir, I had, sir. Yes. If we integrate it from 0 to infinity, then it will be same answer, sir. 0 to infinity,
No, no.
because
Why it
range
will be?
is
See, 0 to infinity means it will be 1.
because range is greater than x, sir. X.
Range is greater or equal to 0. See, 0 to infinity means you are doing f of infinity. That means you are integrating throughout the range. That is, throughout the range, it will be 1. Okay? Are you getting my point?
No, sir, not getting it.
See, you are saying infinity. Instead of x, it should be infinity, right?
Yes.
If you will put infinity here, that means you are going to put, it will be infinity, e raised to infinity.
Yes, yes, that
E
will
raised
be
to
1.
minus infinity is 0, right?
Yes.
Okay. So if it's 0, then it will be 1. 1 minus 0 is 1. Got it? No, are you getting my point? See
But
this,
sir,
see this part will be my infinity. Tell me, right?
I am trying to
E raised
understand
to
why.
minus infinity is what? 0.
Yes.
And this e raised to 0 is 1.
Yes. Yes, sir,
So
that will be 1.
minus 0 minus 1 is what? 1 itself, right?
Yes. Yes.
Okay. So
Okay.
basically what you are doing there, you are simply doing you are integrating the things throughout the range. Okay. If you will integrate throughout the range, that will give you the if you integrate the PDF throughout the range, that will give the value 1. Okay.
Then, sir, how to think that where to restrict the range in this case, sir?
And this is the given to you, right?
Okay, okay,
This can
okay.
be anything. This can be half, this can be 3.
Okay.
You can see,
Okay.
right?
That is there in question itself. Okay.
Yeah. Okay.
Okay.
Right. So next thing is, let me give you one thing. Tell me fx of x. Suppose I'm saying k times x square plus x. Okay, 0 x to 3 and 0 otherwise. Tell me the value of k. Since it's given, this is the valid PDF. If it's a valid PDF, then you have to use the property and tell me the value of k. I will give you some 2 to 3 minutes you can take. Okay.
Two by 27.
13.5.
How much?
27.
27 by
2 by 27,
2
sir.
by
2 by
27.
27.
Okay, let's do. I don't know the answer actually. Let me do. Okay, so it's a okay. So what we have to do? We have to integrate throughout the range, which is 0 to 3 fx of x. We have to apply this property, right? So this means 0 to 3 k times x square plus x dx should be equal to 1, right? So k I can take outside, right? Outside the integration. So simply I can take 0 to 3 x square plus x dx. It should be equal to 1. So it will be k. So it will be x square dx 0 to 3 plus 0 to 3 x dx. It should be equal to 1. Okay. And we know the integration part. So it will be x cube by 3 0 to 3 plus x square by 2 0 to 2 equal to 1. Okay. So k. So it will be I think 27 by 3, right? Minus 0 plus 4 by 2 minus 0 equal to 1.
3, sir. 3, sir.
Yeah, it's a 3. Yeah. Thanks. So it's a 9, right? Yeah, it's correct, right? Or yeah.
Correct, sir.
So 9 plus 9 by 2 equal to 1. So it will get k times 27 by 2 equal to 1. So k will be 2 by 27. So this is the answer. Okay. So so this is something, this all kind of questions you can practice. Okay, this will help you. Because, okay, suppose there is something like that. Okay, suppose in this case, suppose one more thing is there. Okay, let me change the scenario. Suppose a PDF is defined as like this. Suppose it is x square for a range 0 to x2. Then kx square plus x, for example. I'm just taking some dummy example. Then let's say 3 to 4 and 0 otherwise. Then I ask what is the value of k. Then what? How will you do?
Integrate both the value in the range
0 to
solution
2
solve
x
this.
square dx, right? Plus 3 to 4 k times x square plus x dx. It should be equal to 1, right? Okay. That is something you can apply. Okay. Is this clear, right?
Yeah, but in the given example, the entire range, it is not continuous, no?
Which one?
At this example, what you are discussing now,
Mhm.
it is not continuous in the entire range, right? 0 to 4, it is not continuous.
Piecewise continuous, sir.
It should be piecewise continuous.
Okay.
Piecewise continuous is continuous for every range actually.
Okay, so piecewise continuous also you can take in that split fashion, it should be 1.
Yeah, I think there should be some questions in your activity and all. Maybe we can get some questions. I mean, the main idea, did you get or not? Like you like this, you can see.
Yeah.
Like you can see here. It's 0 to 1, then 1 to 2. So here, what you have to do, you have to integrate from 0 to 1, 1 to 1 dx plus 1 to 2 cx dx, then like this. Okay, something this. Okay. So yeah, according to you, it should be 0 to 4, like sorry, 2 to 4. You are saying.
Correct. That is what I am telling.
Yeah, this is something. Yeah, sorry, it should be 2. I by mistake I wrote 3. it should be 2 to 3. Sorry, 2 to 4. Okay, that is something you have to do. Okay, yeah.
Right.
Okay. So I think we have covered the content, right? Or is there any topic which you left out?
Sir, before exam, whether any other session will be there or this is the last session?
Tomorrow is the mock discussion session, right?
Okay.
Have you attended the mock? Because tomorrow is the due date till 6 p.m.
I will finish with, I did some, but not all.
Okay, so tomorrow there will be one mock discussion. I mean, in this session we will be discussing the mock. Okay, questions of mock. Okay, so I think we have covered. Is there any topic which you have left out? If anyone can tell me.
Week-1, Week-2 is already done.
Yeah, it's already done. I think last Friday itself.
Okay, then I'll go through
Yeah,
it.
just go through it. Okay. I think we have done, or is there any topic?
Yes, sir. Yes, sir. We have completed all the topics.
Okay, I think one normal distribution is there, right?
Normally, yes.
Yeah. So what is that? Let me just give you some idea. Suppose axis follows normal, so defined as with mean mu and variance is sigma square. This is called expectation of x, and this is the variance of x. So how to do? Okay, so there is one form called standard normal variable. Okay. So standard normal variable. So what is that? It defined as z equal to x minus expectation of x divided by standard deviation of x. So it will follow normal 0, comma 1. Okay. Then here z is called standard normal variable actually. Okay. So if you see how we are getting 0 and 1, because if you will find the expectation of z from where, that means expectation of x minus expectation of x divided by standard deviation of x, right? Yes or no? So I can do, it will be 0 because expectation, if you take expectation inside the bracket, it will be expectation of x minus these things. It will be 0.
Yes, sir.
And similarly, variance of z, if you see, so variance of x minus expectation of x divided by standard deviation of x. So we know variance of, so this is the constant multiplication of 1 by standard deviation. So it will be outside standard deviation of x square, right?
Yes.
Yes or no?
Yes, sir.
Basically, if you see, and what is this variance of x minus, so expectation of x will be a constant value.
Yes, sir.
Because okay, so variance of x minus will x minus expectation of x will be variance of x, and denominator is also this. This is the 1. So that is something called standard normal form. So where we have to subtract the mean and we have to divide by the standard deviation of that random variable. Okay. And since okay, one property about normal distribution is it is symmetric about mean. Okay. It should be bell-shaped curve. Okay, just treat as a bell-shaped curve. I mean, the peak is at mu. I mean, mean itself. Okay, mean itself mu. If it's standard normal variable, that means mean is 0. So it will be 0 actually. Okay, so that means 50% region. This red region. Okay, it is 50%, and this green region is covered the 50% actually. What I mean means probability z less or equal to 0. This is same as probability z greater than 0, which is 0.5. Is this clear? Are you getting? And since it's a bell-shaped curve, right? If it's bell-shaped curve, so it's a symmetric about 0. It's a symmetric about 0. Symmetric about 0 means if I will say, suppose I have, this is point minus a, for example, and same point a here. Okay, for example, suppose a is here. Okay, just treat this graph as a bell-shaped curve. Here I have not drawn properly. So probability, that probability z less or equal to minus a will be same as probability z greater or equal to a, because it's a symmetric about 0, because it's a mirror image actually. This red region, this red one is the same as the, if you will flip, you will get the same as the green one. Okay, are you getting some idea? Yeah.
Yes, sir.
Okay. So what's the use of in this case? Because suppose I asked probability that 40 less than x less than 60. For example, okay, let me do the another thing. Suppose I'm saying x is following normal 50, 25. Okay. So what is the probability that 40 less than x less than 60? So thing is that rather than doing the, since see normal distribution, the form of normal distribution is not completely integrable. We cannot integrate the things because the form is very tedious actually. Okay. So what we can do, we can find the things from standard normal table. Okay, we can convert in standard normal value in standard normal form, then we can find the values from standard normal table. Normally in quizzes and all we are providing the value. How we can do? Okay, so okay, how we can convert in standard normal form? I have to do x minus expectation of x divided by standard deviation of x, right?
Yes, sir.
So here I can do 40 minus what is the expectation? 50 divided by standard deviation will be 5 because variance is 25, right? Sigma square is 25. Sigma will be 5. Yes or no? Are you getting my point here?
Yes, sir.
Right. So I will write this one x minus 50 divided by 5 less than 60 minus 50 divided by 5. Can I write? So this
Yes,
will
sir, we
be
can write.
minus 10 by 5 less than, and this is nothing but what? This is the standard normal variate. It will be z less or equal to 10 by 5. Okay. So basically from here we are getting minus 2 less than z less than 2. Yes or no?
Yes, sir.
And we know probability a less than x less than b in case of CDF. This is same as probability x less or equal to b minus probability x less or equal to a, right? So can I write
Yes.
probability z less or equal to 2 minus probability z less or equal to minus 2? Yes or no?
Yes, sir, we can write. Yes.
I can write. So if you will be given this value from the standard norm. Suppose I have given fg of 2, value is provided to you, something is there. Fg of minus 2 is given to you. Can you find this value, right? See, here we are will be we can avoid the integration part actually. Okay, there is no need to do the integration. Okay, one more thing is here, if it's minus 2 and 2. Okay, tell me one more thing. Suppose in the case of standard normal variable, it's the bell-shaped curve, right?
Yes, sir.
So can I say minus 2, suppose this is the 2 and this peak at 0. So probability z, I will say probability z less or equal to minus 2. This is same as probability z greater or equal to 2.
Yes, sir.
Okay. So here probability z less or equal to 2 minus, I can write this same as probability z greater or equal to 2.
Yeah.
Correct? Right? Same probability z less or equal to 2 minus, can I write this 1 minus probability z less than 2? Why I'm
Yes,
writing?
we
Because suppose you have been given only fz of 2, then in that scenario actually. Okay. So if this is the case, then I will write probability z less or equal to, since it's continuous, I can write this like this. So minus 1 plus probability z less or equal to 2. Yes or no?
Yeah, we can
So
write.
this is something I can write probability z less or equal to 2 minus 1.
Yes, sir.
Can I write now probability capital fz of 2 minus 1? Okay. If this value
Yes.
is given to you, I can calculate that value, probability that x is lying between 40 and 60. Now you got the idea how to convert in standard normal form and all things, right?
Yes, sir. Sir, this PDF will be available.
Yeah, the PDF I will upload under the supplementary content. Under
Okay.
that there is one section, live session notes. Okay, you can
Okay, sir.
get from there. Okay, within after the end of the session I will upload there. Okay. Don't
Yes,
worry.
yes.
Okay. So I think we have done the things. Okay. So hopefully I think this will be the my last session. Next session will be taken by some other instructor, mock session. Okay. So hope you people got the concept. Okay. So and all the very best for your quiz one.
Thank you, sir.
Thank you, sir.
So we'll meet after the quiz one. I mean tomorrow is one session from 6 to 8, which is mock discussion session. that session will be taken by other instructor, okay, because I have to take some a session in other courses also. Okay. Okay, then thanks all. Hope
Thank you,
you know
sir.
all the concept. Okay, all the very best. Okay. Yeah.
Thank you.
Bye.
Thank you.
Thank you, sir.